The nuclear energy also known as atomic energy, which is the energy released from the nucleus due to a reduction in its mass. Right. So just how we know that when undergo the radioactive decay, so after the certain constant period of time, the original mass of the radioactive source that we had, it will reduce half. Okay, so all the loss of mass, it will release as energy, gamma ray, okay, alpha particle, beta particle also have a release energy. Okay, so all this energy we call it nuclear energy. So this energy come from what? Come from the reduce in mass, and this mass we call it mass defect. So this mass defect converted as energy. It's just like our body also same lah. When we eat a lot, okay, just like me lah. Okay, I keep the energy in our body. In my body, after that, this energy converted as a mass. So I put on my weight. Okay. When I start to go to exercise, so I will reduce my weight. So reduce of weight, this one I call it mass defect, decrease of mass. And this decrease of mass all converted as energy. So energy during my workout, okay, all the exercise that I do, running and so on. So that is a process. So when you reduce in mass, so the mass is converted as energy, and end up with this formula, which is a very famous one. We call it Einstein mass energy equation, E equal to mc squared. So, yeah, everyone when talking about Einstein, so even they are not study physics or what, they're still knowing about this equation, E equal to mc squared, right? But they actually they don't know what is that. Okay, but when you simply interviewed or any people got to study a little bit about science, when talking about Einstein, what formula you know about Einstein, so they will mention E equal mc squared. So, but you know what is that? Okay, E equal mc squared is the one to calculate the energy release due to the defect, mass defect. Okay, and some people say because of this formula, then the scientists created nuclear bomb. If without this formula, scientists won't create nuclear bomb. So somehow there are certain people, they just Einstein in history, they say that because of Einstein, then we have a nuclear bomb now today. It's very unfair actually. Just like people that invented about the knife. You cannot say that, in the inventor of about the knife, so that's why the people use the knife to kill the people. That is a tool. How you use the tool, it depends on you. This is a formula to let you understand how to calculate about energy. And how to use this formula, it depends on the person. It's nothing to do with the person to find to discover this formula, right? Okay, so I really disagree the people mention like that. It's a stupid guy, right? So anyway, this formula equal to mc squared is the one to calculate the energy. Okay, it is specifically for nuclear energy. Okay, and you have to know that we have the main in your fundamental level. We only learn this nuclear release of nuclear energy is only occurred in the three basic process here, which is the one of process we study already just now, which is the radioactive decay. Another two more process you're going to learn in this subtopic is the nuclear fission and nuclear fusion. Fission and fusion. Okay, so for those playing a lot of games or you watch the comic example like the Japan comic Dragon Ball, right? So you may familiar with this word if you play the game in English or you watch you study the comic in English version, so you were familiar with this word, especially when the son of the Wukong combine the two become the one character. So there is a moment that they will pronounce the sound fusion, just like playing a game. So when two character combine become the another one big character, so they will have the sound fusion. So it means that they combine. So two lighter nuclei combine as a one heavier nucleus. So this process is called nuclear fusion. Nuclear fusion. Okay. If from the one heavier nucleus split into a two lighter nuclei, we call it nuclear fission. Right. So you have to be understand the words lah. Okay. So if you good English, will no problem lah. For those like me, right? Okay, last time how I remember easily which one is a combine, which one is a split, right? So I find my way lah. Okay, myself. I use the term here. I. Here got I. This here got you. Right. So I means that it's split. Got dot and the straight. So split means that from one split into two. So 1 heavier split into 2. So we got I. Split into 2. U is what? U got 2 lead, then comma is 1. 2 comma is 1. So this one is a 2 lighter comma is 1 become heavier. So this one is a fusion. Okay. So there's a way for the person like me that's really bad in English. So there's a way I learn. All right. Okay. So somehow the question, it wasn't give you the mass defect in the unit kilogram. All right. It will give you in the atomic mass units. Because the calculation is involved for the nucleus atom. So we don't tell you how many kilogram because it's very small. That's why the information that we get firsthand is in the atomic mass unit. So we have to learn how to convert AMU into unit kilogram. But somehow this one, don't worry, because the question will tell you. Okay, the question will give you this information. 1 AMU equal to 1.66 times 10 power negative 27 kilogram. All right. So what you need to do is you need to convert from the calculation into a unit kilogram. All right. So here as an example, it will tell you that this one, there's a one alpha decay here for the radium 226 alpha decay. So it will tell you this atomic mass unit for the each elements that we have here. All right. So this one for the radium, this one for the radium, so this one for the helium. All right. So what you need to do is this one, you're going to minus the total of these two. You're going to minus it. Because only that you will find the mass effect. Because from this parent nucleus, okay, so after the alpha decay become this lighter nuclei already. This lighter daughter nuclei. So with the alpha particle here, so how much is reduced in mass? So we have to total up these two and minus the original that we have. So for original, after you get to know the mass defect already, is in the unit of AMU. So you have to multiply 1.66 times 10 to the power negative 27, convert it into a unit kilogram. Only the convert into unit kilogram already, then only can substitute inside here to multiply with this constant value C squared. Right? Then only you get the answer in the SI unit joule. You cannot use others unit. You cannot just teacher, if I use AMU later on, I just write AMU meter square per second square. Cannot. Right? We don't really accept like that. So that's why you have to convert so that everything in SI unit, then after final answer in the unit joule. Okay. So this question very easy because they have a limitation of question can be asked, because it's not going to ask you about C, because C is a constant value. And then it only can ask you about the energy or ask you about the mass defect. Right? So it's very limitation can be designed, the questions. Right? So most of the time the cadet mistake is what? Cadet mistake is the student forgotten to do the C square. They should substitute this 3 times 10 power 8. Or when they do calculation, they calculate only. They will make it C square become 3 times 10 power of 16. Because they calculate only. The key calculator wrong. So by right, you should understand the whole together square. The whole together square, actually, you multiply 9 times 10 to the power of 16. Right, so remember about the C square is very important. Okay. And I noticed that there's a new info given in the textbook. This one. The nuclear energy expressed in normally we explain the nuclear energy in the unit mega electron volts. Mega MeV. There is a very common unit to measure the nuclear energy. Last time we don't introduce this, but this time they already put into the textbook, so better you learn how we convert a unit in joule into the MeV is given already. 1 MeV equal to 1.6 times 10 power negative 13 joule. Right. So I'm not sure whether it will be given. By right, it should be given during the exam. Right. But I worry that it will be like it will be like the way we convert degrees Celsius to Kelvin. The question won't tell you how to convert degrees Celsius to Kelvin. You should know. Degrees Celsius convert to Kelvin, you have to minus. Okay. So no minus. You have to plus 273. Kelvin to degrees Celsius, you have to minus 273. This one is not given in the exam. Right. So, but for the 1 AMU convert to kilogram, as usual, they were given. But for this one, I'm not sure. So better you try to memorize it. Right. 1.6 times 10 power negative 13 joule. Biologically, it should be given because the value is not easier to remember. Right, so this is a new one. So it means that once you use the formula E equal to mc squared, the final answer, you get the answer in unit joule already. So after that, this answer you divided this answer you divided with the 1.6 times 10 to the power negative 13. So you will get the answer, final answer in unit megawatt. Okay, mega electron watt. Right? Because that is how we find how we solve the question. Just only another process lah. All right. Okay. So if they really put into the design of question, it may give you let's say a nuclear energy. A nuclear energy is a 2 MeV. What is a mass effect? So you have to do a lot of the process to convert unit. So first one, MeV convert back to joule. After substitute the joule into the formula, divided by the C squared, they only get the mass effect. For the mass effect already, and then after they ask for answer in the AMU. So you have to reverse all the steps. Right? So it may design the question like that. It's just only the mathematical problems. All right.